So these are the notes for the second part of section 4.1 and then also for the beginning of section 4.5. If you'll notice the example that you have, it says the graph of the derivative of a function is given. So this is the derivative. And we are to sketch the graphs of two functions that have the given derivative. So in other words, we want to sketch the graph of the original. It does say to give two examples. Okay, so I can tell that this derivative graph is always... Okay, that's the dogs. Sorry about that pause. I can tell that the derivative graph is always positive, right? Because it's always above the x-axis. So if the derivative is positive, that means that the original function is going to always be increasing. Okay, so I know I'm going to draw a graph that's always increasing. But the other thing to keep in mind is the derivative graph went from decreasing to increasing, right? And it changed right there at x equals 2. So that means that the original function is going to go from concave down to concave up, and it's going to change right there at x equals 2. That's the last part of your magic chart. So not only is the original function increasing, but it's got to change from down to up at x equals 2. So somewhere along this x equals 2 line is where it's going to change from concave down to up. So maybe if I can kind of give it a little bit of a curve there, it's concave down, and then it changes and it's concave up. So that might be a possible example of a graph of the original function. But notice it said that they want us to give two possible graphs. Well, remember how we talked about if this is the derivative, the original function might have had a particular constant that was added or subtracted, and the derivative would still be the same. And so if you think about it, if you have an original function, say f of x, that plus or minus c, what's that going to do to the graph? Well, that's just going to be a vertical transformation, right? It's going to either raise the graph or lower the graph. So really, any graph that is always increasing, changes from down to up along that x equals 2 line, would be a possible graph of the original function. So they said to draw two, but I mean, I could draw as many as I wanted to. Notice they're all the same basic shape, but just with a vertical transformation. Okay, next example, if you look at example 2, this time, instead of being given the graph of the derivative, we're given the equation for the derivative. And notice we're given an ordered pair on the original function. Well, what's missing here is the rest of this should say find f of x. In other words, find the equation of the original function. Well, I know that the original function is going to be whatever I get when I integrate the derivative, right? And so if I integrate 4x cubed minus 2x plus 1, think about it. When I integrate 4x cubed, it's going to be x to the 4th over 4, so x to the 4th. When I integrate 2x, it's going to be x squared. And when I integrate the plus 1, I'm going to have an x. And then don't forget, anytime you integrate, you have plus c. Well, so I've found f of x, but I haven't found the exact f of x. I've found what's called the general solution instead of a particular solution. If I want to find a specific solution, instead of having a plus c, I can use this ordered pair, and that's going to help me find the plus c. Well, f of x is the y value, right? So 5 equals, let x equal 2 to the 4th minus 2 squared plus 2 plus c. So I should be able to solve for c. Let's see, that would be 12 and 2 is 14. So I think what we have is 14 plus c, and so if I subtract, I think that's going to tell me that c is going to have to equal, what is that, negative 9? So that means the actual function that they're looking for is, the function is x to the 4th minus x squared plus x, and then instead of a plus c, I'm going to put minus 9. So that's the specific function that goes through that point. So if you think about it, when I had plus c, it could have been any one of those possible transformations like we had listed above. I mean, this isn't for the exact same graph, but that's the idea. But this time they said, no, I want the one that goes to a specific point. So just like up here, I might have said, hey, I want the specific curve that goes through the point 2, -2. Well, that means I would have had to give you this one here. So that's kind of like the idea that's going on here. So number 3, notice the directions. It says solve the differential equation. Okay, solve differential equation means integrate your way back to finding the original function. So I want to find the original function, but notice they give me the second derivative. Well, I'm just going to have to do the process we did for example 2 twice. If I integrate the second derivative, which is x to the -3/2, is that going to give me the original? Well, no, that's the second derivative. So that's going to take me back just to the first derivative, right? Okay, so this is just going to give me, all right, my pins do crazy things. Okay, so like we were saying, I'm integrating the second derivative, so that's only going to give me the first derivative. Okay, well that's fine, let's start there. So this is going to come out to be, when I integrate x to the n+1 would be to the -1/2. Instead of saying over -1/2, I'll say times -2 plus c. Okay, so this is the equation of the first derivative. If I want to find out that plus c, I'm going to use this ordered pair that is from the first derivative. Okay, so if the y value there is 1, when I plug in 0 for x, so I would have -2 times 0 to the -1/2. Okay, so all of that is 0, so c is just 1. So that means that the first derivative equation is -2x to the -1/2, and we said c was 1. Okay, well, again, if I'm supposed to solve the differential equation, I want to take this all the way back to the original. So I could do the exact same process one more time and take that back to the original function. So I'm going to come up here and I'm going to say, if I want to find the original function, I'm going to integrate that derivative, that -2x to the -1/2 plus 1. All right, so that's going to give me, leave the -2, x to the n+1 would be x to the +1/2 times 2. The integral of 1 is x, and then plus c. So again, I'll plug in, this time I'm going to use the ordered pair from the original function, 1, 5. So y is 5. Now I'm going to plug in 1 for x. So this is going to be -4, 1 to the 1/2, plus 1, plus c. So let's see, square root of 1 is 1, so -4 plus 1 plus c. So if that's -3 and I move it over, so c must be 8. So again, that means what they were actually asking for, the original function, is, where'd it go? -4x to the 1/2. Okay, sorry, I don't know if you heard all that barking, but my dogs are a breed that is known for barking, sorry. Okay, so let's see, f of x, -4x to the 1/2 plus x, and then the c is 8, so plus 8. So there's my original function. So something I wanted to point out, the first half of your homework, which is over 4.1, is related to these 3 examples. So you've got a whole homework packet. You'll notice the first example that we did is going to be like 45 and 47, where they give you the graph of the derivative. You're supposed to sketch the original function. The next 2 problems, number 49 and 53, are like example 2. Now, notice in 49, they give you the equation for the derivative, and I know it's a strange notation, but basically here they're saying that the derivative is 2x minus 1. And you don't need this picture, but what they're saying down here in this picture is these are the possible graphs for the original function, right, depending on the value of c. And so what the directions are saying is, what if it goes through the point 1, 1? What if it goes through the point 1, 1? So in other words, you know f of 1 equals 1. So use that when you integrate to find the plus c. Same thing down here on this one. There's a whole lot of words and a lot of different things, but again, on this one, they're giving you the derivative. So they're saying that the derivative of the function is cosine. They give you this ordered pair for the original, so they're saying that f of 0 equals 4. We're going to use that to find the plus c. And down here, instead of giving you the graph of all of those original functions, they're giving you something that's called a slope field. And they're saying if this is the point 0, 4, if you were to kind of follow those little segments, just kind of the slope of those little segments in both directions, it gives you kind of a basic shape of the original function. Okay? As I was saying, the last part of the 4.1 homework is going to be very similar to example 3 that we did in the notes. Now, I do want to point out your homework is not just the rest of section 4.1. So you'll notice this is the part from section 4.1, but it's also the first part of 4.5. And you'll see right here it starts section 4.5. This is also going to be what's due on Wednesday. And for the notes to show you how to do these types of problems for 4.5, that'll be the next short video.